That one. This one. No, that side.
My way on the whole wear my sneakers.
Come and carry the money. I don't carry. Carry the money.
Come on, Sarah.
Dora. Good morning, everyone.
That's my phone.
Glory, glory, over me, carry me, carry me.
Oscar.
If I'm going to listen to this thing later on YouTube.
They play. You're not happy as I calm down and answer you, Shibi. You're not happy as I calm down and answer you that one.
That let's say the way she used this time, you change, but you don't make my eye. But you know, when I feel stay, you don't go prepare, you can be at the same as stay. But you don't make my eye red. I don't have pepper. She said, don't worry, but make I but just the pepper. I want to see for the time. I don't take pray for that baby she finish. God.
Get his shadow.
I know, man.
Okay.
Not say before she put all those things. She know they drag this thing come up very well. And if you see and you go not say you go see say the glue gone no be on top of the lash. They glue to the lashes. That's why I'm saying. I understand. But not before you just
You guys, you know there's a drama. I almost want to give you English.
For this one, they glued to the down very
So good morning, class.
Good morning, ma'am.
Don't shop up.
Okay, can we mute ourselves? I apologize. I sincerely forgot that the class was meant to be this English. I forgot about the class time. So my apologies. Please, can you mute yourselves? Precious, one goma. Please mute yourselves, please.
I'm muted already now. What's she saying?
Yes, let's start the class, okay? Let's mute ourselves.
Oh, no, no, it's so grenade inside.
Rachel, let's mute
Like,
ourselves. We
just
just have a few minutes to spend now. Who are my course reps?
Good morning, ma.
My course reps, good morning.
That's so good.
Who are my course reps, please? Olariwaju, are you a course rep? Shukura, are you a course rep? I hope I'm not spelling your names. If there is any course rep, please let the person indicate.
I know like
I don't like I want to sabi am. To be laying down like this on
you know hard now.
and I like we done the play. I will do that time bomb.
Oh, what?
Yourself now.
This one show
Okay. Okay, let's continue. We are talking about the reactions of benzene. And we talk about that benzene undergoes electrophilic aromatic substitution reaction. Costre, please help me to always control the class. So we talked about the sources of benzene to be coal and petroleum. And we said that benzene cannot mix with water because it's oily. It has lower density than water. And we also talked about the unsaturation of benzene that can be detected by a flame test by showing sooty flame, just like the soot, just like charcoal around the pot. So that's a sign of sooty flame that shows that benzene is unsaturated. And we also talked about that benzene being unsaturated cannot undergo the other reactions of unsaturation, like decolorizing bromine water and undergoing oxidation of permanganate because of its aromatic nature needs to be protected. When it undergoes that kind of reaction, it loses its nature as benzene. And remember, somebody was talking, I was asking question that why is it that benzene double bond is not real? The bonds are not real because they are always revolving. They are being delocalized. It means that they don't have any particular position. You can say this is where the ring is. And that's why we have canonical structure of benzene. So because the rings are always delocalizable, they are not real rings, real bonds. And because the bonds are not real, they cannot undergo addition reaction. because the bonds are not real, and because these bonds are not real, and when they undergo addition reaction, they become cyclocompound. They lose their identity as benzene. And because benzene wants to remain benzene, it must not undergo any reaction that can affect its identity. Addition reaction would destroy the aromatic sextet of electrons of benzene. So, and the molecule formed will be less stable than the resonance stabilized benzene molecule. So because benzene wants to retain its aromatic nature, it cannot undergo addition reaction. Please note that. So we were talking about the reactions of benzene as electrophilic aromatic substitution reaction. Remember I said every word in that sentence is very important. It must be electrophilic. It must be aromatic because we're talking about aromatic compound. And it's not addition, rather it is substitution. That's the reaction. It can do with by nitration, sulfonation, halogenation, and Friedel-Crafts reaction. Now, in that reaction, we talk about one electrophile is being substituted by hydrogen being an electrophile. So that's what all that happens. And I say for this reaction to occur, the first thing you're going to do is to generate the electrophile before the electrophile will attack. For the sake of 213, you're not expected to tell us the mechanism, but a question can be shown which of the following is correct about a generation of nitrophile, electrophile in nitration reaction. So this step 1 can be a question where they show you different reactions that indicate that this is how I can generate my electrophile in nitration of benzene. So if you don't know the correct equation, you can miss the steps. So you have to note this equation and understand that we need 2 mole of sulfuric acid for this NO2 nitrophile to be generated. And remember, it's NO2 plus, not NO3 plus, because you can also see NO3 plus. You can also see NO plus. You can see NO2 without any sign. You can also see NO2 minus, as the case may be. Just understand that the electrophile you're dealing with is NO2 plus. Any plus is an electrophile, and NO2 cannot be minus to be an electrophile, become a nucleophile. So I want you to understand that so that you don't make mistake, because something about CBT, you can easily pass it and you can also easily fail it. You might know something, but because it's objectives and you didn't look well to look at the options critically, you choose one that are likely to be, but not exactly the correct answer. So that's why you have to be careful whenever you're doing your CBT. Make sure you read in between lines. Don't be in a haste to make options, to choose your option. Then, okay, we'll talk about a sulfonation reaction. What you're looking for is sulfonic acid. You're not looking for SO3. You're looking for SO3H. That hydrogen is important. That's what made it sulfonic acid. If there's no hydrogen, it cannot be, so it will be sulfur trioxide. So because of hydrogen, it becomes sulfonic acid. Just understand all the electrophile we need in these reactions. Okay, so that's the maximum you might be expected to know in this mechanism in terms of CBT. The people that are going to do chemistry in higher class, they should understand how mechanism goes. Then in halogenation, we are using iron 3 halide. It can be bromide. If you're doing bromination, it should be bromide. If you're doing chlorination is fluoride, and the case may be. And remember, in that case, bromine is becoming an electrophile. Normally, bromine, as we know, is a halogen that is electronegative. But in this reaction of halogenation, every reagent is going to generate an electrophile. So whether that compound naturally is supposed to be electronegative, but because is 2. Remember, in reaction, we were taught I can have two halogen, and one become nucleophile, another one become electrophile because of direction of my bond. In that case, whenever I want to break this bond, though they are similar, my arrow is going to move towards one. And wherever my arrow is moving to is going to be nucleophile. And when my arrow is moving away from, it's going to be electrophile. So that's why we're going, in this case, we're going to have one bromine that is electrophile, another bromine that is nucleophile. The one that is nucleophile is what is added to the catalyst to make it be arrow 4 minus. So that is halogenation. We also talk about Friedecraft. You have to understand that what we need in Friedecraft is Lewis acid catalyst, which is aluminum chloride. This aluminum chloride is what the catalyst is for all the Friedecraft reaction, whether you are chelating or you are acylating. Both acylation and acylation uses one thing in common. That's what they have in common, is their catalyst. And their differences is that their products can either be alkyl, benzene, or ketone. So for acylation, you're forming ketone, and from alkylation, you're forming alkyl benzene. The one thing they have in common is that they must have a common thing, which is the Lewis acid. Another thing they have that differs them is their reagents. Why they both can react with benzene? In alkylation, we are using alkyl halide. Why in acylation, we are using acyl halide. So that is, they have one thing in common, they are catalysts. Differences are the reagents and the products. So I want you to also note that. We talk about their limitations. Now, we went further to talk about the effect of substituent on benzene. And I said that what makes benzene to be reactive is the substituent on it. So when we have methyl on it, the benzene becomes toluene. And I also said that whenever you see a question, when methyl is on benzene, don't choose methyl benzene as an option. The most better correct option is there is toluene, because the toluene is a family name or compound name for methyl benzene. So whenever you're having, say, what's the name of the following structure, and you saw that the methyl is on benzene, please don't call it methyl benzene. If you see toluene as an option, either use toluene is much more accurate. Now, I say because of this methyl on benzene, it becomes more reactive. Benzene is more reactive. So methyl benzene is more reactive than normal benzene. Because if you look at the past question, you realize that they said the reactivity of the following, which of those following is most reactive? They can give you benzene, methyl benzene, chlorobenzene. Now, if there is the activator on a compound, it is less reactive than the compound. Example, if I have NO2 on benzene, that's nitrobenzene, and I have benzene, and I have methyl benzene, the most reactive there is methyl benzene, followed by benzene, and the least reactive is nitrobenzene, because the NO2 there is deactivating. The activators makes reactions slower. So it means that the reaction is slower than the original compound for the activators. Why activators? The reaction is going to be faster than the original compound. Now, the original compound we are talking about here is benzene. The substituent on benzene can make it faster or slower. So activators are electron donating, so they make it faster. The activators are electron withdrawing, so they make them slower. I hope you understand this explanation because it's very, very important. Toluene undergoes nitration by 20%, 20 times faster than benzene under the same condition. It goes faster because of the presence of methyl, which donates electron to the benzene ring, making it more reactive. I also gave us an instance of how excited you are whenever you're having alerts, and how that's why some people, they like collecting money, they don't like paying, because payment when there's debit is deactivating, but when there's alert is activating. So it makes you excited. So that's what happened to toluene and benzene. Benzene does not have anything on it, so it's just neutral, no money, no alert. Why toluene has an alert? So toluene is very excited, while benzene is just there. But when benzene start having something that takes something from it, it becomes weaker than its normal self. So this is an example of activators. This methyl benzene, which is toluene, reacted faster. And remember, we said there must be two products because they are auto and para directing. So they're going to have auto product and para products. Then I said this issue of percentage is what is dictated by synthesis in the lab. So you don't need to go and start cramming their percentage because it depends on the reaction. So by this reaction in the lab, the percentage he gave us tell us that para is giving us lower yield than auto position. So this is not what is supposed to cram. Now we'll talk about this, about functional group attached, making it either activators or deactivators. And just like I explained, nitro group are deactivators, they slow the reaction. So they make benzene weaker. So weaker means deactivators. Stronger means activators. And when they are stronger, they react faster. So and I told you to make sure you understand these electron donating and electron withdrawing groups. What are they? At least you should know the common ones. If you look at the strong activators, you can see hydroxy group, you can see amine, you can see primary and secondary amine. So you can see the moderate activators and weakly activators are all alkyl groups. Alkyl groups are weakly activators. Then we also talk about deactivators and deactivators that auto-para. Because halogens has lone pair of electron, so they can donate. That's why they're auto-para. But they are deactivators, and that's why they're meta position. So remember I said they're going to occupy dual position. They are auto-para directing, and they are also deactivators because they reduce electron density. If you look at this slide, you realize that halogens are always withdrawing. They withdraw by inductive effect and they donate by resonance. So that's why you can say, how can it be donating and also withdrawing? Yes. So that's why they occupy dual position. They have strong donating and they have strong withdrawing by inductive effect and weak donating by resonance. So that because inductive has priority, so that's why they are meta directors. They are deactivators. And because of the electron donating by virtue of lone pair of electron on halogen, they can donate by resonance. So that's why they're auto-para directing. So they're auto-para directing because of their weak resonance capacity because of the electron pair. And they are deactivators. They are deactivators because they have strong inductive effect. They can withdraw by inductive effect. So the arrow is anyone that is going in is telling is activators that they're releasing electron. While the ones the arrow going up, meaning they are withdrawing, they are deactivators. So all halogens are deactivators. Aldehyde are deactivators. Tetrachloride are deactivators. Just like I said, that the group can either give increase or decrease. Now, this is mostly understood by terms of resonance. Whenever there's electron donating, you can also feel resonance. Whenever there's electron withdrawing, that we have positive and negative charge. That is what we have when we were talking about the mechanism, where we are seeing positive and negative. In auto-para, we see that negative charges on position 2, 6, and 4. While in meta, we see they are positive in all those sizes, meaning that electrophile cannot attack those positions. Electrophile is positive center and can only attack negative centers. So when there is positive, it means that place is no go area. And when there is nothing, that's why we have meta in electron donating. So this is a typical example of amine. Because there is lump of electron, it can donate by resonance. So it has strong resonance, and that's why it's auto-para directors.
Give me your more.
Now, the same thing that happened, we look at NO2. If you look at NO2, you realize that those positions that we are having negative in amine, we are having positive sign in NO2, making all these positive centers not to be available for any electrophile to attack. And the places we don't have positive is where electrophile can attack. That's why they are meta directors, being NO2. Then if you look at halogen have strong electron withdrawing by inductive effect. the weak electron donating by resonance. Because of the electron donating capacity it can do, that's what we are talking about autopara. You can see now why is it meta directors? Look at the position 3. That's why we see negative, right? But there in that position 3, there is negative. Now, if you look at that position 3, by virtue of where my halogen is, that position 3 is position 2 normally, right? Because if you want to count, you don't count because my benzene is 6. It must be on carbon number 1. Wherever your substituent is carbon number 1. So if you look at my carbon number 1 and carbon number 6, they are the same thing with what we have in amine. So because of that position, with that position is position 1, position 2, position 4, and position 6. These are the positions that are available for electrophilic attack, and they are autopara. But because this halogen has electron withdrawing capacity by inductive effect, that is one and that inductive effect is very strong than resonance. So that is why it is deactivating. Deactivators are electron withdrawing. So the electron withdrawing capacity of halogen, that's why halogen is confusing. It has both electron withdrawing and electron donating. So it has both autopara directing and deactivating. I hope that's clear. Hydroxyl and amino groups have weak electron withdrawing if inductive but strong electron donating resonance. Hence, they are activators. While halogen has a strong electron withdrawing and weak electron donating. That is why they are meta directors. This is a summary of what we are talking about. Now you can see methyl are activators. All activators methyl has weak electron donating. And by inductive effects, they don't have anything by resonance. By hydroxyl group, that's why they're weak activators. Now, if hydroxyl group, amine and primary and secondary amine are activators. They have weak electron withdrawing, but strong electron donating. So that's why they are strong. They are the strongest in strong activators. Now look at the activators of halogen. Halogens are autopara because they have weak electron donating, and they are the activators because they have strong electron withdrawing. All strong electron withdrawing are the activators. Okay. Now let's look at addition reactions of benzene. Remember we said that benzene cannot undergo addition reaction because it's going to lose its character of being benzene. So these are the reactions of benzene. Addition reactions of benzene can be addition of halogen, hydrogen, and ozone. Now, addition of hydrogen, we call it hydrogenation. Addition of halogen, we call it halogenation. And ozone reaction, ozonolysis. So whenever benzene undergoes addition reaction with benzene, that's hydrogenation, we form cyclohexane. And just like any other catalyst that we need for our hydrogenation reaction is involved, they use platinum, palladium, or nickel as a catalyst. In that case, because we have 3 double bond, we are going to need 3 mole of hydrogen molecule to form the compound. So in that case, benzene is no more benzene. It has become a cyclo compound. This is what benzene wants to avoid. It wants to retain its identity. That's why it does not like this reaction called addition reaction. In that same manner, benzene can also undergo chlorination. That's by using free radical mechanism. In that case, this happens spontaneously using UV light. And in that case, the same thing that happened in normal hydrogenation is also happening in halogenation. We are going to have tetra. We are going to have hexachlorocyclohexene. Hexachloro because 6 chlorine. All the chlorine will be, there will be substitution of double bond. All the double bond will be saturated with chlorine. So we're going to have hexachlorocyclohexene. In terms of ozone, when it just like what happened in alkene in alkene, benzene, when it reacts to ozone, it's going to be unstable and it's going to stabilize to form a compound we call ethanediol. So these are what happens when benzene undergo ozonolysis. It's going to form an unstable ozonide, which is going to hydrolyze to form ethanediol. So these are the reactions. So I have to ask a question about benzene, and any question you want to ask about this topic, you have the floor now to ask it. Benzene and aromaticity. In a recap, we talk about benzene as a compound that is highly unsaturated. It refuses to undergo reactions of unsaturation because of its aromatic nature that it is want to protect. Just like we've seen in this last slide, whenever benzene undergoes the addition reaction, it turns to something else. Its identity is lost. So because benzene wants to retain its identity, that's why it hates to undergo any reaction capable of destroying its aromatic nature. And I will also talk about that the substituent on benzene affects the reactivity of benzene. Substituents can make benzene react faster or react slower. So if I have a compound like, look at the following compounds. I have toluene, I have aniline. Remember, toluene is when I have methyl on benzene. Aniline is when I have amino group on benzene. And I have NO2. Then I have benzene. So name them A, B, C, D. I'll say which of the following is most reactive. Or I said arrange this compound in order of their reactivity, increasing reactivity. So how will you arrange it? Somebody can help us answer. Bring your biro and paper now. Bring your biro and paper. Option A, arrange the following in order of their reactivity, increasing reactivity. Because that's some of the things that make people to be confused. Increasing reactivity. Number 1, A is toluene. I know by now you know the structure of toluene. So write toluene. I would have loved you to draw toluene. Then B, nitrobenzene. C, benzene. Then D, aniline. Aniline is ANILINE. 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 So I need an unmute and tell me the answer. Arrange the following in order of the increased reactivity. So which means from the least to the highest. Remember, toluene is same as methylbenzene, yes. If you're sure, just unmute and talk.
Nitrobenzene,
aniline comes first. The
aniline.
nitrobenzene
Okay, let's go this way. Which one is the
Benzene
least reactive?
Nitrobenzene.
aniline.
Nitrobenzene is the least reactive.
Okay, followed by
Benzene.
then followed by
pH3. Toluene.
toluene. So the strongest is aniline. So is anybody confused with this arrangement? If you're opposing the arrangement, let me see your hand up. So it's a sign that we understand that. So if people that are still feeling that this thing is not correct, please go back and look at the slides again. Look at the slide again. So you must know that you also understand the activators, high activators, weak activators, and moderate activators. Make sure you know at least two of them. If you're talking about it now, you should know all the compounds that are activators. You have all your aniline, the primary and secondary. You have your hydroxyl. They are the strong activators. Then when you know the weak activators, you know the others are moderate activators. Weak ones are alkyl groups. Then you talk about the activators. You talk about the NO2, carboxylic acid, esters, aldehyde, ketones, and others. Then and cyanide. Then you talk about halogen. Halogen are autopara, but they are the activators. Please make sure you're conversant with those things. You need them because you don't know how the question will come. So make sure that however the question comes, you're able to answer them on this benzene and aromaticity. So the floor is open for your questions. Any question? If you have question, raise up your hand so that I can give you a chance. Now, another thing you have to know, understand this question. Whenever the question say,
Yeah? I'm there now. Oh, Lily.
at times the challenge we have is understanding the question. If the question say increase in reactivity, it means that I have to move from the least to the highest. If it's increased, my arrow will move from nitrobenzene, connect to benzene, connect to toluene, and then end in aniline. But if they say decrease in reactivity, my arrow is going to move down from aniline down to nitrobenzene. Please understand that because at times they can come in movement of arrow. Okay? So ask questions. Any question? Silent means there is no question. So okay, Oya, MFN fortune. The floor is open for you. Ask your question. Unmute yourself, Fortune. FMN Fortune. How did she raise up her hand and she's not around?
Good morning. Good morning, ma'am.
Good morning, Steven.
Yeah, ma'am, I'm not clear about the reason for like the reactivity stuff.
So no question in benzene and aromaticity, right? So well, if you still have question, you can see ask the question on the general platform. Okay, Oluderu, unmute and ask.
Well, can you please explain that for the craft again? I don't really understand it.
Which of them? Is it acylation or acylation?
I think it's all of them.
What don't you understand?
Like, I don't really get.
Fidecraft is a reaction that's undergo using Lewis acid as a catalyst.
Okay.
We have acylation and we have acylation.
Yes,
Difference between them is that in acylation we are using acyl halide.
Okay.
And with acylation we are using acyl halide.
All right.
Acyl halide is RCl. So R can be methyl, ethyl, or whatever. Acyl halide, RCOCl. That acyl, that ketone, that CO is a ketone functional group that makes us to have the byproduct as ketone. Remember, in all the reactions, we are going to lose the halogen.
That's one.
So when you lose halogen in acyl halide, you're going to form acyl benzene. When you lose halide in acyl halide, you're going to form ketone because that CO functional group is going to be attached to the to benzene. So now what I said in essence is that that whenever you're talking about acyl halide, the substituent, the ketone substituent is going to connect directly to the carbon of benzene. Then the methyl, remember acyl is CH3CO. So the methyl will be connected to the carbon. So you're going to arrange this in such a way that a ketone is formed. So look at the slide now. You can see that carbon is going to the carbon that of Aselium is going to connect directly to benzene.
Okay.
Why the alkyl group is going to be a substituent, so we form a ketone. So if you follow the way it is and said, okay, my O is going to connect, you're going to miss it. It's not O that is connecting, it is carbon that is connecting to form the ketone. So that's what you have to understand, especially for people that are going to do chemistry in higher level. Because if is when we're having pen and paper, theory and OBG, you'll be expected to write this reaction and tell us how this ketone is being formed. But just know we are forming a xylem, which is the electrophile, but in alkylation reaction, we are using alkyl, which is my electrophile. Then we talk about there is always problem of rearrangement. That's limitation of alkylation. There's always limitation. There's always problem of rearrangement of limitation. And we also say aryl halide and vanillic halide cannot undergo Friedel-Crafts alkylation. That's number one of the limitation. Another limitation is rearrangement. Because if you're not using just simple alkyl like methyl, if you're using primary, remember primary is different from methyl. Methyl is one carbon. But when we have more than one, we call it primary. Now, for you to talk about primary alkyl, the carbon that bears the chlorine must have at least two hydrogen. But if you look at the alkyl, the carbon is bearing 3 hydrogen. That's why alkyl is not primary. In primary alkyl, the carbon that bears the halogen is going to have 2 hydrogen. But in secondary, the carbon that bears the halogen will have 1 hydrogen. In tertiary, the carbon that bears the halogen will not have hydrogen. So now, whenever you're using primary alkyl and your alkylation, there will be arrangement. It's going to form secondary. And you can see secondary is 65. So the major product is going to be 65. We're going to have 2 products at that matter. But when you're having when you're using secondary, you're going to form tertiary. There is always skeletal rearrangement whenever you're using any other thing other than methyl. And we also have something like polyalkylation. So polyalkylation is one of the limitations of Friedel-Crafts. And all this limitation is not seen in Friedel-Crafts acylation. It's only in alkylation. Because acylation has only one product, which is ketone. But because of alkylation, you can use any alkyl. R can be anything. So that's what made alkylation to have more limitation, unlike acylation.
Now I wanted to turn bicycle. Now they bother myself about.
Any other question?
Yes, ma'am.
Good morning.
Ma, what are the reactions of benzene, that electrophilic aromatic substitution and nitration of benzene? Ma, I don't understand anything there.
What is it? The mechanism?
Yes, and that nitration of benzene, I don't understand it.
Now, this is nitration of benzene. What don't you understand?
My everything.
Like what? Is it like you don't know how the electrophile is being generated, or this mechanism of movement of resonance? Is it this resonance that is the problem?
Yes, ma, I don't understand it.
Now, the resonance should not be a problem to you. See, every benzene has C6H6, right?
Yes, ma'am.
Now, in that first ring you saw, we are telling you that this double bond, that carbon that bears double bond, also have 1 hydrogen.
Yes, ma'am.
Now, when for electrophile to come and bond, the double bond needs to break. And remember, if double bond, I want you to, as I'm talking, to be drawing it on your paper so you'll understand. Just draw the ring and put double bonds. Let that be conjugation. Single bond alternating double bond is conjugation.
Okay.
Now, if it is conjugated, now you can pick from any carbon, any double bond. Any carbon that connects to the double bond is where the reaction is occurring. So pick from any points. Now, look at they're picking from point carbon number 1. Now, for the electrophile to come and bond there, that bond is going to break into 2. So use your hand to break that bond into 2. One will be positive and one will be negative. Is it broken? Now, when you break that bond, you put positive into 1 and put negative into 1. Remember, if you want to break bonds, you're going to, the arrow will show you where you want to break the bond to. So if you're moving your arrow to where the arrow is moving to, is going to have negative. Where the arrow is moving away from is going to have positive. So break your bond in that angle. Break it, direct your arrow to one place. Then wherever you direct your arrow to is a negative sign. So that negative sign is where the electrophile is going to come and bond. Now, what you're leaving behind is positive sign, right? Now, that same manner that you moved to break, to introduce the electrophile, which is moving the arrow to generate negative, you continue in that manner. So what I did first to have positive behind me, I will do it again. So when I'm moving that arrow on the next carbon of the, remember I'm dealing on bonds. My target is where there is double bond. I want to break the double bond. So I've broken the first double bond. I attach electrophile and I have positive left behind me. Now, why they put hydrogen? That hydrogen can also be done without. It's telling you that in that positive center, there is also hydrogen, like any other compound have hydrogen, one hydrogen. So I can say I put one hydrogen in every of my carbon center, but it's not that you can also do without it. That's why after the canonical form of one, you didn't see any hydrogen again because it's not necessary. So you can do without it. Now the essence is that I have to move in a way to neutralize this positive center by creating another negative center. Well, how do I do it? Excuse me.
Sir?
I'm coming.
When I put camera and told me to start for you. When I put camera and told me to run for you.
What? Yeah, mine said. Okay, sorry. So what I'm saying in essence is that remember the updated positive center. So I have to move my arrow in the same manner. Now my arrow is going clockwise. So I have to continue in that clockwise. I have to continue in that clockwise direction now. So I'll move my arrow in clockwise direction, and my arrow is going to the carbon. So all the wherever the positive or negative is on the carbon centers of this benzene. So when I break this other bond, I'm going to move it. Then there is negative in the carbon that started that double bond, and I have positive in the substitute in the carbon before it. So because I have positive and negative, I'm forming new bond. That is why you saw new bond on canonical structure 2. And behind that new bond, behind the new bond is a positive center again. So I'll continue moving that direction again to create another negative center to create another bond. And at the end, I have another new bond formed and positive center is remaining. So there's no other bond to break again. So what I need to do is that for this hydrogen to go so that the compound will remain stable. So whenever the hydrogen is going to go by moving that arrow in the same manner. My arrow is moving in. I have to move arrow in the same manner so I can create negative center on that carbon that bears the hydrogen. That's why the hydrogen is going to break in. When it breaks in, it's going to release negative center to form another new bond. Then my electrophile will stand on itself. Now, the canonical structure 4 is a hybrid. It's a summary of 1, 2, 3. So that is a hybrid. Do you understand? So now the positive at the center means that all the four positions, all the 3 positions are positive. That's why we have the 2 auto and 1 para. And that is why this is for auto para directing. That's now auto para directors. That's why we have positive everywhere. Now, in this positive everywhere means that in normal reaction, this is mechanism that we are talking about. But if we are talking about electron donating, difference is not like this. Because in these positive centers, if you look at what we are talking about, what can only attack is the activators. Because we have all these centers, anything coming in now, this electrophile coming in, anything that's coming is going to come to meta position. Because this electrophile, what we have here is going to be a deactivator. Because the position 2, 4, and 6 are all positive. So anything coming in cannot attack position 2, 4, and 6. Now, when we have an example of aniline, let's go. This is NO2. This what we saw is a typical example of what will happen in NO2 in nitration. Because my NO2 is going to be meta-directing. Position 2, 4, and 6 are positive. Nothing can come there. So that's why they're going to come to position number 3 and attack. That's why they are deactivators and meta-directors, NO2. But if you come to aniline, you realize that the difference is the same, is different story entirely. Let's example of aniline. Look at aniline. When we did aniline, because NO2 there is the nitrogen there is electron donating. Now you realize that the position that we have 2, 4, and 6 are negative, unlike the one we have when we are doing the mechanism. That one is positive. In that case, any other thing coming will attack because we are dealing with electrophile. So when electrophile are coming, they can attack position 2, they can attack position 4 or 6. That's why they are auto-para directors. Why the one of NO2 are meta-directors? Because position 2, 4, and 6 are all positive. So electrophile cannot attack them. They can only go in position 3, making them meta-directors, making them deactivators. Fortune, are you done? Is that clear? FMN and Fortune, is your question cleared?
Why is that you ask question? You will not stay in the class to listen to the response.
Please help me tell them all. They just want to ask questions. Well, if she's not around, I know somebody have benefited from it. Life is choice. So, if you have any other question, ask before we close the class. We end the class.
Good morning, ma.
Good morning.
Ma, please, sorry to disturb. Most of us have not gotten the soft copy of the past question.
I don't know this. The people that came to my office and collected past question, why are they not responding to it? I will look for another past question and share. But I know those students, when I see them, I will not be happy with them. Please, if you're here in the class and you're among the 4, are there 3 students that came to my office and I gave them past question? If you're here and maybe you're not the one that collected it directly, but you're among the 3 people that came to my office, please, if you don't know how to do it, bring those past questions back to my office. Okay? The truth I want to tell you that if you want to read and pass alone, it's not possible for this course. Everybody must pass together. Everybody must pass together. So don't hold anything. The best way to succeed in life is make people succeed. Don't feel like you want to. In this University of Lagos or in high institution, there's nothing like first position. So make sure you share knowledge.
Dr. Anita, ma.
I can hear you.
Sorry, my mom called. That's why. So
okay, Fortune.
Yes, ma. So you were talking about that nitration of benzene.
Fortune, it means that your mom, it means that you didn't even understand what I was explaining.
Like that's so dumb. Like when people are just very.
So the only thing is that look at go to the recording version and see what I said so that I can understand it. Okay.
Oh, okay, ma'am.
Yeah. Any other question? I will look for past question and I will share. But the ones that I gave to people, they should please return it to me or they should share it too. Okay. Now, I don't know. The coordinator will also communicate with you whether there will be another class again before the new year. Okay? And if you have any other question, you can also ask me. But from New Year, like I said, we are going to be having a Zoom, YouTube discussion on questions. We are both the one I just taught you now and the ones that other lecturers are going to teach. That is the norm I used to help people that did 213 last section. By having that online tutorial, most of them did very well. Even people in biological science, they did well. So we're going to start it. So especially people in mentoring team, that's the sense of mentoring. So we're going to start it by January. But I'll look at the time that is convenient. By then, everybody would have settled and the seasonal mood would have been off. So we can start. So we'll be doing it maybe on a Saturday. Maybe 1 or 2 hours on every Saturday. So we'll do it period to the exam so they can really equip for the exam. But for now, I want you also to optimize the time of watching the video on the YouTube, recorded version of the class on YouTube. So that you can, because some of these, the more you read, the more you understand. You can go on the, you can also download. So just make sure that you hear the recorded version. This class has been recorded and other classes has been recorded as well. So optimize it and ask questions. You can ask questions on general platform. If you're mentoring platform, you can ask questions on mentoring platform. You can also ask questions on the YouTube channel. I will respond to you. Please don't be shy of asking questions. Okay. All right. Please, attendance is very important. My co-host for today, Adeyaju. We have to find the monument to death. Please help me to take attendance and share it, because this attendance will speak on the day of reckoning. Thank you very much. Enjoy your end of the year. Merry Christmas and Happy New Year. Enjoy your season. Make sure in this season you also read your books, because there's so many Christmas before and there'll be more. And that there was so many Christmas before now and there'll be more ahead. But optimize this season because of what you're pursuing, which is your career. Okay? I wish you the best and bye for now.
Thank you, ma.
Thank you, ma. Bye, ma. Bye, ma. Thank you, man. Season greetings to you, ma.